and the aim is given an array A of n elements. Your task is to print all those indexes that have greater value than its left and right neighbors. In case of extreme indexes like 0 and n minus 1, check with their single neighbor. First, coming to the aim, you have to understand that they asked that, suppose let us take output as an example. Here it's the array which was given from the user, and what they are asking is, suppose let us take index number 0. If the index number 0 is greater than the neighbor element, we have to print it. Here index number 0 7, which is greater than 2, so it was case satisfied. Now coming to next index number 1, which was 2, which is not greater than both of the index numbers, so index 1 is not the special index. And coming to index 2, 8, which was greater than 2 and 4, so it's the case satisfied. Checking all those special indexes are 0 to 2, 0, 2 and 5. We have to print everything in the same way which was given by user. Now coming to the program, we will start with hash include standard input and output dot h, which all of us know. I would define a function void find special indexes int a int n. Here in this function, what we do is, first we repeat the loop from I equals to 0 till I equals to n, and we increment the I value as if see, at extreme values, at extreme indexes like 0 and n minus 1, we have to check with the single neighbor. In case of index 0, we have to check with the right side neighbor, and in case of extreme value at n minus 1, we have to check with its left value. So first coming to index number 0, I have to check with its right value, which is which index number was increased by 1. So if a of I is greater than a of I plus 1, in case of I equals to 0, suppose at here for index number 0, it should be greater than index number 1. For index number I, it should be greater than I plus 1. If the case was satisfied, I have to print the value. I have to print the value I. Else if, now coming to the last number, since the indexing starts with 0, it will be up to last number will be last index number will be n minus 1. Else if I equals to n minus 1, I have to check with it left value. Here the index number, last index number was 6, which now I have to check the index number 6 with index number 5. So index number 6 if index number 6 is greater than index number 5, I have to print the index number 6. So if index number index number a of I is greater than a of I minus 1, I have to print I. So remaining all the elements are between a of I and a of n minus 1 index numbers. So if I is greater than 0 and I less than n minus 1, it resembles all the elements in between the first and last elements. In these elements, if a of I is greater than a of I minus 1, if a of I is greater than a of I minus 1, and if a of I is greater than a of I plus 1, I have to print the value of I. So the program is completed. Here we are calling this function when we need. And coming to the main program, we are asking the user to enter the size of the array, which would be entered by the user, and we are scanning it. And next we are also asking the user to enter the elements of the array. We are also scanning it. Now we are printing the statement special indexes are, and we are calling the function which would go to here and would execute all this function, and will get us special indexes like 0 to 5. Now enter the size of array. I entered the size of array as 7, and then we asked to enter 7 elements of array. I entered 7 elements of array as 7, 2, 8, 4, 3, 9, 1, and the special indexes are 0, 2, 5. 0 is a special index because index number 0 is greater than its neighbor index, and 2 is a special index because it was index 2, 8, which was greater than both of its neighbors, and index number 5 is special because index number 5 consists of 9, which was greater than both the neighboring arrays. And this is the program which was asked by the aim. Thank you.
This is Uma Shanmuki. Our problem statement is To write a C function to demonstrate numerical integration of differential equations using Euler's method. In this program, we use two header files. Hash include stdio.h. It includes the standard input or output library for functions like printf and scanf. And hash include math.h. It includes the math library for mathematical functions. Function f. It defines a function f that represents the derivative of y with respect to x. In this case, it is minus 2x minus y. Int main. Int main, where the program execution begins. Variable declarations double y, xi, yi, xf, h. Declares variables for the current value of y, initial value of x, initial value of y, final value of x, and step width. User input. The program prompts the user to enter the initial condition for y and x and the value of x for which y is required and the step width h. While loop. This loop iterates until the current x value reaches the final x value. Y is equals to yi plus h into f of xi comma yi. This is the core Euler's method calculation. It updates the current value of y based on the derivative function f and step size h. Yi is equals to y. Updates the initial value of y for the next iteration. Xi is equals to xi plus h. Increments the current x value by the step size h. The results are printed in a tabular format showing the current x, y, and the derivative y dash, product h, y dash, and the updated y. Final output. After the loop completes, the final values of x and y are printed along with computed value of y. Output. We enter the initial condition for y as minus 1 and initial condition for x as 0 and the value of x for which y is required as 0.4 and the step width h as 0.1 and we get the output. And the value of y is minus 0.768300. Thank you.